Hello everyone, so this is a nice tutorial on how to make a Screwjack body as part of our Screwjack assembly, which we're going to be going through. This particular tutorial is going to show you how to use the Revolve command and to look at different features that we can include on our Screwjack, such as internal features, threads, and how to create a nice diamond knurl which you would have physically for any 3D printing or just physical rendering effect. So let's get to it. Okay, so obviously we're in open up Fusion 360, and the first thing I'm going to do is just save my drawing so it just automatically saves. I'm just going to call it Screwjack tutorial, and I'm just going to save it in a location that's fit for me, so just my admin project folder is fine. So, what does the drawing currently look like? So this is the current drawing, and I'll put a link in the description as well, so you can access this. This is a Screwjack body, which is part of a Screwjack assembly, which is again used within the engineering industry. It's a three-part assembly as well. So, a couple of features. Just want to point out, it's 50 mil in diameter externally. It's 65 mil long, and it also has a 30 mil internal diameter with tapers that are 20 degrees. So, just going to zoom into this particular part here. This particular drawing is very much different. This half, so this half above, is what we class as the external view. This half below, which we can see at the bottom, is the internal view. So essentially, you can see the external features and the internal features on the same element of the drawing. So it's a half split drawing. Medium nail I indicated on the external edge as well. So let's start making our screwjack. So I'm within the workspace. All I've done is save at this point. So, and obviously I need to draw within my function. So as I said, we're going to use the Revolve tool to do this. So essentially we're going to draw half of our profile and revolve it around a center of axis. So to make this nice and straightforward, I want the front of my piece to be essentially on the front here. So that's looking at this section here. And I want this to then be like the left-hand edge as well. So obviously for top, front, right, we're going to draw on our right plane to make it nice and straightforward. So because it's only 65 long and 50 high, get a nice kind of view for here so you can see your image nice and clearly. So first off, what I'm going to do is just draw my line 65 mil, and I know it's got to be 50 high. So obviously we're only going to revolve this around the center point, so I need to draw half of the axis, and obviously it's going to be 25 high. So just to stay in that sort of perspective, and I can get a nice kind of clear starting point. Okay, so I'm just going to insert my canvas. This will just show me, stop me from basically moving screens the whole time. Manipulate, move that. Let's go slightly above. From here, I just need to rotate it around. Wow, hopefully a bit bigger. Just so I can see it as a kind of shape. I'm just going to pop this, zoom out a bit, move everything over, pop this just about there, because that's going to be sort of the length that I'm looking at. Okay, that. So what we're going to do is we can see our features here. So 65 long, 45 high, 50 on the external limit, and then we've got our features. So we're going to basically put this 10 mil this side here. So we know that this sort of feature here is 25. Just move that one. It's demonstrated just down here. 25 there. So first of all, what I'm going to do is start with this bottom left-hand edge. So 12.5 high. Okay, and then we're coming in 10 mil. And that's all I can do on that side because I don't know this length Next, what I'm going to do, I'm just going to tweak this to actually 22.5. That'll be my starting edge at 45 degrees. I need to come in 8 and then come up using the L hotkey, coming up fairly 2.5. Hotkey again L, coming out further 15. L coming again, down about 2.5. Coming out distance, which I don't know. And then hopefully going to drop down the angle to get the angle correct. We're going to do the angle in a second. So I'm just going to exit that one. I'm going to run my measurements. I know it's 28 from there to there. So 28. Getting everything nice and sort of linked up. Now what I'm going to do is do a tangent line run off of my 10. I know it's 20 degrees. Enter. That's obviously matched the 2. I'm just going to trim out these components here. Get my feature. So that's basically my feature there. I come and just check a couple of dimensions, make sure everything is okay. So I'm just going to remove the 2.5 here and here because we don't technically know it's 2.5, but we have to presume. So actually, we do know from there to there is actually 50, but that's 25 millimeters, just to make it accurate as we can. This one here, again, we don't know the dimension, but we know it's 28. So that is actually reference 15. I think it's fine. 45 high, 2.5. And that's so. Now at this point, we can revolve the whole feature. We can actually include the internal detail as well if we wanted. So you can just revolve it, leaving the internal features. So I'm just going to populate the internal features now. So from a center line, again, okay, we're coming up 15 millimeters. So I'm just going to populate 15. Coming along. So I've got 8 plus 15, just using the system's advantage here. And 3. And this is where I go into this steep kind of 20-degree element again. So I'm just going to do another line, run it down. Hopefully parallel maybe. So just make it bigger than what you need, so you can trim it off afterwards, make it look fine. This time we've got an M12, so we know the hole's from 12 mil. So again, just run up 6. L and run it straight past and trim out the 2. Okay, so essentially this is what my profile now looks like. I'm going to leave that line in down the bottom. Because obviously that's what all the dimensions are running off. But now when I go into solid, I can do a revolve, choose my profile, choose my axis, and I've got my internal and external shape. I'm just going to hide that image. Now when I rotate it around, I've got my 12 mil hole. I've also got, when I flip it around the side here, I've got my internal features already inside. It's just a nicer way to do one big sketch together. So next up, what we're going to do is just make sure that that is actually a tapped hole rather than just a hole at 12 mil. So what I'm going to do is just draw a hole in its face, come round to the front view, pick my reference as the center point. Okay, now it's actually not picking up any kind of reference because I have actually already made the hole. So it won't actually let you put a tapped hole through. So if we just put through because it essentially has nothing to cut, so you can't actually use the hole feature here. What you can do instead is come down and use the thread feature. So I've seen quite a few people on the forums have problems with this. They make a hole, forget it's tapped, and you go, oh, you need to go and change it. Actually, if you just come in and make that a threaded hole, it picks up the size and you just okay it. So you actually can use that technique, which you can't actually use in stuff like SolidWorks as easy as using Fusion. So it's always a good sort of top tip there. That's my threading. I've got my internals, 20 degrees. Now what I need to do is put on my chamfers. So go into modify, into my chamfers, Okay, now the chamfers here are all 2.5 type equally spaced. There's 4 of them. So what I'm going to do, come in, select this one, this one, this one, and this one. Now if you just double check, there's actually a chamfer on that back side as well. So I'm just going to spin this round and just choose that back feature face. Like so. So you have 5 edges, and then quite simply 2.5 mil. Okay, and then hit the enter. Add the error there because I put 2.5 meters, and there's our shape. Now, what you can see on Fusion is actually you can see the internals here because I've got an internal feature. You can actually turn it off using display settings, visual, and either just using shaded, or you can come in and choose shaded with visible edges only. So you're just not getting that internal overlap as much. So what's left is that technically this is now fit for purpose. I can take this into a drawing and be fine. And what I could do is just indicate here that it is a medium knurl, exactly the same as what's on my drawing here. Essentially, it's just indicated and indicate there. However, if you're doing 3D printing or you want some rendering prototype, you actually need to put this feature in here. So this is quite a good technique on how to put in a feature. So if you put a coil, you run the coil on the front face. Okay, you put the center point as the middle. We need to draw it as the largest diameter that we have, which we know is 50 millimeters. Okay, it'll put a nice coil through. So I don't want a whole continuous rotation. I just want to use a factor of it. So I'm just going to use 25% of that rotation. Okay, my circular, I want to use triangle internal. Okay, the height, I'm going to kind of leave the same for a second, but I might actually change it to 65 just to get the full width. Again, I'm just going to spin around to the right view and see what I can see here. So it is intersecting quite nicely there. Section size, I just want 1 mil. Okay, you may or may not be able to see, but if you actually look on the front view, this isn't actually touching my shape until it intersects with my top of my chamfer up here. And it only actually cuts then the top element of that part. It doesn't touch any other elements of that shape, so which is important. If you're smaller, you'd be cutting into more of the shape. So 25% of the revolution, 65, which is the height. Essentially, it's height moving down the screwjack. Internal triangular. Okay, that. And what it's done is put a nice little cut for me at the bottom of my feature there. So next thing I just need to do is just mirror that. So I'm going to mirror it on a features, choose my feature down the bottom, choose the feature coil. Okay, I'm just going to mirror. So I'm going to, rather than click on the faces here, I find it easy just to go to the origin, and I'm going to choose the XY feature. So just populate it sort of roughly halfway above. Okay, that one. So now I have a mark on the top and a mark on the bottom. They're not actually in the center. It doesn't matter at this stage because what we're now going to do is pattern that. So I'm going to create pattern, circular pattern. Again, just change the features. Make sure you choose the coil and your mirror, so you get both halves. Okay. Axis, you can just choose any basically circle you want really, but I like to just pick a cylinder because if the cylinder ever changes, it's effectively the same. Now, I would choose optimize for this before you punch in the quality because it's going to use quite a lot of power. Because what we're going to do is put in 100 of these, which will then make that nice crisscross pattern you can now see. And obviously, if you use any of the adjust or identical, adjust actually makes it potentially different copies of the pattern. I mean, this includes more features. We're just using this for visual interpretation. Identical is basically it's replicating identical features. So we just need optimized here. Let hit compute the best way to put this on. Then hit the OK button. And what it would do is a little bar will pop up in a second down in this corner here. Okay, and it will just process that you're putting on a secondary kind of feature that's just using some power. So be patient at this stage because if you start clicking and thinking, why is it not responding? It will crash your computer. So it is just got a link into the server and just put a bit more power for it. Okay, so that sort of took about roughly about a minute. So but now you can see that actually when I zoom in, I've got this nice diamond nail. Now, because I've got a chamfer on, it does unfortunately cut into the chamfer. Um, but if you don't do the chamfer first, you have to pick up all these little individual faces. So actually, when you would machine this in real life, you would put the chamfer on after you've done the nail because it obviously makes a nice tidy feature. However, Fusion doesn't like it, and trying to go around and doing 200 edges of both would just be a nightmare. So for me, I'm happy with that little bit of an overlap. So and actually, it replicates what you see in real life. You wouldn't remove all of the nail anyway at this stage, but make sure you save your update. So you can just use a save. Okay, and that is your Screwjack feature all ready to go. The next stage is you could just output it to a drawing. So just going to use the drawing workspace now, which will just bring it in. Again, because we've oriented this properly, front is the front, right hand side we did a lot of the modeling on. And the top feature will then appear in the correct location as well. Once again, just be patient at this stage. Sometimes it can take a couple of seconds just to load in and pull everything through your internet connection. Or if you're like me, you've got quite a lot of software on your laptop. Okay, so it's all loaded up now. It's brought in my first view. So essentially, this is my front view, and it will propel off one side. I can actually, if I wanted to, I could change that and put maybe the back if I want to see on the back first. But it is important to see whatever orientation that you want. So I can put my front view first. I could put scale in, so I wanted it slightly bigger. So I could use like 2:1 if I wanted to. So actually, I'm going to do that. Make it a bit bigger. 2:1, and then again, you can show like different features. Threads if you want to show threads as well, and then you got the shaded option or shaded with hidden edges, or you just got visible with hidden edges. So it's kind of important to show whatever you think is necessary at this stage. So for this all intents and purposes, because it's quite a lot of hidden detail, you should put visual edges only. What I do is now just show the external features only, none of the internals. Okay, so it's got my thread seeing, I've got my external edges. And remember, guys, because has got a lot of minor features with the no, it will take a fair amount of time to process. So don't sort of worry if it is taking a long time. Second, I'm just going to project off to the right hand side to confirm. Again, it's just a lot of the processing is going to be this null, which is why a lot of people in the industry, just for effectiveness, they won't include that null. But as we know, for design purposes, it does look kind of cool. So it's sometimes important to use. So what I'm going to do now is just use the section view, which is my parent view, which is going to be that one. And I'm just going to do a half. You could do a half split, I suppose, actually, rather than a section. But you could actually just do a section view. You can say I'm going from there to there, and project up or down, depending on what process that you sort of want. So you could put a nice projection view further up as well. Pop that there. And what I'm doing is just going to drop my other two drawings down so they don't overlap. Like so. So I've got my section. There and there. And again, it shows the internal view. The other view you could do is you could do like you could actually put like a break point through. So you could actually come in and make a break section view. So you could do like a half view. Again, so if you're coming in, just come in and do like a there to there to there view, like so. So you literally just drawing like a broken out cut view, like so. Yeah. So let me when it loads, pop that one there. I know it's not out of the shape, but just quickly process. So yeah, it'll show you then the internal view as well, but I kind of don't really want that, so I'm just gonna get rid of it, and then I could actually just trim out and only look at half, but because it's got quite a lot of important detail, I kind of want to include it really. So next stage is then just to start essentially running your um, dimensions really. So let's have a look at populating some dimensions. I can use like the D tab now again because of we've used the actual knurl. This can be quite tricky to get the correct points. Just make sure you're zooming in. It should be 50. So I'm going to get a lot of 49s here, like so. So it's actually 50. You have to sort of like remember that as well. Maybe you can stuff like whole call out. So you could call out the thread. You could put notes on as well, so you can kind of justifiably look at different components as well. So you can sort of um, pick up its diameter 20, make sure it's coming out nice and clear. And second one is diameter 25. So you can come in again, bring your 2.5 radius. Now what I like to do is just sort of you could tweak that so you could just put it's actually 4 times. You can double click in and just put 4 times 2.5. So just know that all those chamfers are all exactly the same. Again, you can actually come into the dimensions tab and get the angular dimensions from there to there, which can overlap and look a bit messy. So hence why it was on the other one was written rather than physically shown. But essentially down here would be quite a nice way to show it. 20 degrees. Come in again. So pick up point to point. 10. There to there is you actually know that one before, so there to there was 8. We knew that there to there was 15. And then we knew that there to there was 28. There's space for a bit of a premium at the second here. Just picked up as well actually my drawing is actually slightly wrong there, so it should be 28, not 27.53. So I'm just going to reduce the scale down this one as well. Scale factor, so I just half scale it. So I'm just going to change the scale down to 1 to 1. just to make it a bit more clearer. So now I picked up that point, so I'm just going to go straight back into my sketch here. I'm going to see what essentially went wrong. Because it is actually 28. What I didn't realize there is that I actually picked the point that didn't exist. So if I now go from there to here, now I get a 27. So now I'll change it to 28. Just tweak everything for me. Now that to reprocess. And then we go back to the drawing, update the drawing, which is why I like using Fusion. Because it has automatic up and dates, which keeps everything nice and concise. Okay, so let's now process that. Going back to my drawing. It will now bring up here that something's not out of date. So I'm just going to save it and just put updated 28 mil. Good to put a description, so if you ever do come back, you know what the changes were. Now it's saying it isn't reference. If you now look at 27.53, I'm going to click this one, re-reference to the other drawing. It's updated. It's now the latest version. And once it's processed it, that 27.53 will change to 28. Like so. So there it is within the 28. There's also another thing that the 15, it's just picking up, it's no longer associated. So you just come in, double click as well. It gets reassociated like such. So there we go. So there's a particular component. Now I can focus on my internal one. So just picked up the AA is actually too high. So let's bring that down. So that is a completely different scale. Just going to dimension some key components here. So I'll call out. Not gonna work at this. There's 30. Put a note in, so that's 12 times 1.75 in there. Put like 20. The symbols, but 20 degree. Again, just make it nice and clear. Like so, if you want, you could probably put a bit more dimension on than what was on the other one, like so. But again, because it's an internal feature, it's kind of not really going to be the same throughout the whole picture. So you have to be careful what you're doing. But you do get, it's 30 and then obviously 12 on either side, so it isn't necessarily too much. So that's it really. So there's my sort of constructed shape. I could save that, populate the title block, and output it to PDF and give it to my machinist to now make. So just hit the save. Screwjack drawing. And that's the process. And that's the process using the Revolve tool. So you can also do this additively, and you can do it subtractively as well. So I hope you understood the tutorial and it's useful. Thanks for watching.